All right, so we are on 1A.4, understanding error and defining residuals, okay? We're going to be talking about least squares regression lines is what we're going to be diving into. So on your paper, it folds in half and it makes a little booklet. So you have one booklet, part one, and you're going to have another booklet, part two, and we're just going to make one pocket in our folder for 1A.4 to put both in. Does that make sense? So we're going to make one pocket. We're going to turn page 9 into a pocket. We'll do that later. I'm going to do it right now. But you're going to make one pocket, and then they'll both go in that one pocket. Make sense? Yeah? No? There's a? All right. So we're on part one. So on part one, we're talking about scatter plots, which we've already talked about. So we discussed scatter plots. Now, what we're talking about is the residual. What does residual mean? Well, residual means your actual Y value minus your expected Y value. That's called your residual value. So when we were doing our line of best fit, notice that our line that we created wasn't necessarily going through all of our points, right? And so when we're looking at it, this is the residual amount. This is the distance from our estimated point in our actual point. Okay, so if we were to find the residual amount, our scatter plot point. So these are our given. I can write. Let's try that again. Okay, these are our given values, and then these are our expected values. So when they say given, that means that these are your actual data collected. So if I wanted to find the residual, so for example, if I wanted to find the residual at x equals 1. So at x equals 1, I'm going to go here, and I want to know what is the value of that red space, right? So it's going to be your actual y minus your expected y. What was our actual y? Our actual y is 2. And what's our expected y? 1.4. So our residual equals, if you have $2 and you spend $1.40, what are you left with? 60 cents. So 1/6. That's how you calculate the residual. How do you feel? All right. So to help people remember residual, I kind of changed it to residual equals your actual minus your predicted instead of your expected. And just remember, we're going to rap about it. We're going to rap about it. Let's rap about it. So our residual equals our actual minus our predicted. And that's what your residual is. It's the distance between your given and the expected, the one you found from your linear regression. Okay? How do you feel? Your residual means your actual y minus your expected y. It's that distance. Okay? Can we go on? We're good? Yes. Residual? Yeah, at x equals 1. So we did our residual at x equals 1 as an example. All right, I'm going to pause for a second, and I would like for you guys to tell me what is the residual at x equals 4. So you're going to calculate really quick. What is the residual at x equals 4? What is the residual at x equals 4? Not 0.2. So we're measuring the here. This is x equals 4. Remember, we're rapping about it. What is your actual value? So what was my given value? 4.3, but we're looking at the y. So my given value was 3. I said at x equals 4, right? And then what was my predicted value? 3.5. So what is my residual? It's going to be a negative 0.5. Does that make sense? 3 minus 3.5 is negative 3.5. That is what it's asking you to do when you're calculating your residual. All right, let's dive a little deeper. Okay. Okay. Residual means your actual y minus your expected y. Your regression model is your expected, your predicted. Yeah. Your actual is the data that they collected and you use to make the regression. Okay. All right. How to minimize error. So we're asking ourselves, how can we minimize error? And one way to determine how well a linear model best fits the data set is by squaring the residuals, okay? And examine the sum of the squared values. Does that make sense? So we're going to square the residuals. And the reason why is that when we are squaring it, it's going to eliminate whether it's negative or positive, right? Why do you think we would square it? Well, here's your answer. Squaring the residuals ensures that all result values are positive, okay? And we're not going to end up canceling out values. So that's why so the main part here is we are squaring residuals so that we can maintain positive value. You see that question on your paper? That right there, I underlined it, squaring the residuals and examining the sum. Yeah, that's what the blanks you're filling in. So you're on your first one, these were your blanks, squaring residuals and examine the sum. Okay. All right, geometrically. So coming from geometry, what does it mean when you are squaring something?
Multiplying it by itself.
Multiplying it by itself. But geometrically, what were you usually, if I'm squaring something, I'm finding the what? The what? Not square root.
No.
Areas. Okay. When you are squaring something, we are finding the area of the square. Okay. And ideally, you want it to be as small as possible. The smaller the area of the area, the closer to the expected you are, the better your model is. Does that make sense? So the smaller space there is between, the better it is. Okay. So as you're writing, you either can paraphrase that last part. But the key things here are we're squaring and we want smaller the area, the closer it is expected. The expected is to the actual value. And that's what you want. You want to be as close to the line as possible. All right. So today, does it sound like we're doing a lot of hard math? No, we're not. We're subtracting and squaring. Can you subtract?
No. Yes.
I hope so. Can we square?
No.
Yes. I should be hearing a lot of more yeses and then instead of a loud no.
Maybe.
Okay. And that's what we're going to be focused on. Ready, Freddies? Yeah? Okay. You're fine. You're not the one. Remember, you're my stop sign. So, you need me to slow down or stop? Not done with you.
Yep.
All right. So we're going to put this to practice, right? And we're going to see based on given information which best fits. As we're doing this, you may see that these people numbers may look like your discussion if you started your do now discussion. So we're going to practice finding the residuals. We have Stella, Jasmine, and Brainy went on a road trip. Every so often, someone wrote down how long they had traveled in minutes and how far they had traveled in miles. Each person later created a scatter plot in their own equation to represent the data. So this is their data. So everyone has the same given information. Agreed? All right. Our job here is to see who was the most accurate. All right. So at first, you either can remember using the calculator to create our table, graph, put all that in. We're going to do that. And then we're going to talk about how to do it with Desmos. Cool? So the beginning is going to be the same as our yesterday. And then it goes from there. So I'm going to pause for a second and allow everyone to grab a calculator and get situated. All right. So here we go. I'm going to clear Sylvie. Second plus 7 1 dose. And we're going to put in the given equation. So the first thing it wants to do is we're going to put in the given equation. So our given equation for, who is this? What's her name? Stella? Is it Stella? Yeah. So we're going to put in Stella's equation. In order to put the equation, we're going to press y equals. And her equation is 1 in 400 x plus 3.46. That's Stella's equation. Agree? Mm-hmm. So we're going to change the window to fit our graph. So when I have my graph, I can see a line, but I'm not focused at the points that I need to be, am I? So I'm going to change my window. So I go to window. I know that I'm only in quadrant 1. So I'm looking at the table that they gave us, the graph they gave us. It says 0 to 200. So in your notes, the table is, do we see that? 0 to 200. And they're counting by 25s. Agreed? So my scale factor is 25. And it's going to be the same on the y, 0 to 200. And the scale factor is 25. Is there anyone not seeing where I'm getting these numbers at? Easy peasy? Ah, perfect. Thank you. We're going to hit graph. And now we have the information in. And now we're going to find, so we have our actual values. Now we're going to find our expected values. To find our expected values without having to do a whole lot of work, what we're going to press is second trace. So we're following the notes. We're going to press second trace. We graph. And then we're going to press second trace. And we're going to go to 1. What this is going to help us do is find our expected values. So our expected y values. I need to move this so I can change my pin. Okay. Okay. So I'm going to hit 1. And now I can start finding my values. What we're putting in, so these are our actual y values, and we need to find our expected y values. These are our x values that are going to stay the same for everyone, right? So we already have our actual. Now we're going to find our expected. And again, we press second, then we pressed trace, and then we pressed 1. So up first, I'm putting in 30. So I hit 30, and I get 34. 0.66. Still with me? Now I'm going to do 62. Type in 62, and I get 67.94. So I've now done 62. Now I'm going to do 85. Type in 85, and I get 91.86.
Good job for everything.
Now we're going to do 124. And we get 132.42. Now we're going to do 151. The wrong way. There we go. And we get 160.5. And then we have 185 left. We do 185. And we get 195.86. Okay, how do we feel about using our graph to find our expected values? Doable? Perfect. All right, our fourth step is we're going to press second mode, and we're now going to find the difference, which is our residual. Okay, so we're going to find the difference between the two numbers, and then we're going to square the residual. So I'm going to go to second mode. It's going to take me to my calculator page. And I'm finding the difference between 30 and 35.66. So we get 30 minus, and you may not even need the calculator to do it, but. So there's my first one. Yes. So we get negative 4.66. Okay, and then I'm going to square it. So when I want to square, I'm going to square my answer. And because my answer is negative, when I square it, I have to make sure I put it in parentheses. So to square your answer, you're going to press second answer and then square. And that's going to give me my residual squared. And my residual squared is 21.716. We'll do to 3 decimal places. How we feel? All right, we're going to do the next one. So we're now on to x equals 62 to find its residual. So we have 65 minus 67.94. We get negative 2.94. We're going to square our answer. And we get 8.644. So we have negative 2.94. And we have 8.644. Okay? Answer. Oh, second, negative. And that'll allow you to put the answer in. Yes, because it is negative. When you're squaring a negative, you have to utilize parentheses. Second, negative. So you're going to press second, then negative. Okay? Negative. So we have one. I'm going to do it again. 102 minus 91 and 86 hundredths. And then do I have to put this one in parentheses? No, because it is not negative. So second answer. And I'm going to square it. And there's my square. So we have 10 and 14 hundredths and 102.82.
Wait, isn't it 11?
What's 11? No? You have to borrow, regroup.
What?
You have 102.00 minus 91.86. So you had to regroup. 2 times?
Oh.
You think the calculator is lying to you? Oh. All right, so again, 130 minus 132 and 42. And we get, and then we hit second answer. Why am I putting in parentheses again? Because it's a negative. And when you square a negative, you have to utilize parentheses. So we have negative 242 and 5856. Last, we're now at x equals 151 and we're finding its residual. So we have 165 minus 160.5. And I'm going to square it. And we get, we have 4.5 and we have 20.25. Now we have x equals 185 to find its residual. So we have 190 minus 195.86. It's a negative, so I'm going to use parentheses to square. And that gives us negative 586 and 34.34. How do you feel about finding residual? Good. Okay. Now, the residual, what's most important is the sum, the total, right? How do I find the total? I'm going to add up all of these numbers, and that's going to give me my total. Your goal for your sum is to be as close as possible to 0, right? The closer you are to 0, the better your answer is, or the smaller your squares are. If it's 0, then woohoo, you did a perfect one, right? It's like perfect in your model. However, the likelihood of that in the real world situation is slim because you're going to always have your randoms, your outliers, those things are going to always take place. Does that make sense? All right, so we're going to find our sum. So to find the sum, I'm going to add all these numbers together. So we have 21,716 plus 8.644 plus 102 and 8200 plus 5 and 856 thousandths plus 20 and 2500 plus 34 and 31. I got 193. You typed in something. If you need to correct, just arrow up and you can hit enter and you can correct and double check that you typed in your numbers correctly. You don't have to retype it completely. So I'm double checking that I wasn't the one who made the error. I'd rather it be me than you. I didn't find one, so sorry. Don't quit. At least not today. 193.626. Okay, how we do? All right, so this is method 1 of using the calculator to find residuals. Method 1 is you're pretty straightforward. You do a little bit more up front. All right, now we're going to do method number 2. Okay, so we're going to use, this is going to be method number 2.